All right, let's get started. So we're going to continue from before where we talk about if statements, if else statements, and if it leaves else statements. All right. So we have these three conditions that we need to write. So you first ask for user for quiz score, enter as a digit, and then we do a float. This is called typecasting because user input is always as a string. If you want to make comparison as a number, we either do float or int. In this case, because I allow the user, for example, to enter 3.5, so I do float instead of int. And now if the point score is at least 4, you should display that you get A. If point score is at least 2 but less than 4, you get B. If it's less than 2, you get C. And now we're going to create this program. So if you do it literally as the questions, you will run 3 if statements. But these 3 if statements, they're sort of redundant for certain input. For example, when your quiz score is actually, say, 5, perfect score, then in the first test, 5 is already greater equals to 4. So you already print you get A. Okay, so you already know that 5 is greater equals to 4. Then 5 would definitely then this 5 here will not satisfy this condition here. It will satisfy the first condition, 5 is greater equal to 2, but it would definitely not be true that 5 is less than 4. And the same thing, 5 will not be less than 2. So the moment you know that it is greater equals to 4, it becomes unnecessary to test this condition. It becomes unnecessary to test this condition. So which promise to write it in a different way, where we want to use the if-else statement. So once the condition is true, we don't test anymore. You get A, and then we go to print exit. If this condition is false, that means quiz score is actually less than 4. We need to do this test here. If this is true, you get B, and then you exit. However, if this condition is false, all right, you don't print you get B, rather you print you get C, and then print exit. Now, the same thing as a programmer, you always want to optimize your code. You don't want to run 3 if statements because for the first statement, you already know what quiz score is going to be in the range going to be. So again, the same thing. We ask, can we optimize the following code? So when you know that quiz score greater is not greater equals to 4. So if this condition return false, you're going to do the subsequent test. The subsequent test will do 2 things. Check whether it's greater equals to 2 and check whether it's less than 4. Now, this part here is unnecessary because you only execute these Boolean expressions. You only execute line 4 after you have run line 2. Okay, after you have run line 2 and know that it is less than 4, then only you run line 4. Okay, which means you already know that quiz score is less than 4 before you run this line 4. Okay, so here, if quiz score greater equals to 4 is true, then you already get A and exit. If quiz score greater equals to 4 is actually false, that means you know it's already less than 4, then it's unnecessary to check again whether it is less than 4. Okay, so this becomes redundant. So again, we can further refine this code, saying that we actually don't need to test whether it is less than 4 because you already know it from the first test. From the first test, you already know whether it's going to be greater equals to 4 or less than 4. So it becomes redundant to do it again in line 4. Okay, so this will be the final optimized code. Okay, now what if I have more? Here we have three output. Either you get A, either you get B, or C. But now if we have more outputs possible, say if the point score is at least 4, you get A. If it's at least 2 but less than 4, you get B. If it's at least 1 but less than 2, then you get a C. But if it's less than 1, you get a D. Again, we make a simple assumption that user inputs correct input. All right, so in this case, we will require to have more else statement. So it will be the same as before, okay? Except that now we will have one more else statement in between. So if it's at least 2 but less than 4, so this is at least 2, we don't need to test whether it is less than 4 because the first condition already tells us whether it is less than 4 or not, okay? So you get B, And then we'll have an else if statement to check whether quiz score is at least 1. Okay, if it's at least 1, you get C. Okay, so you print you get C, for example. Okay, now we don't need to test less than 2 here. We don't need that and quiz score is less than 2, because again, the same thing. You only run this statement after you run the first statement, subsequently run second statement, then only you run this statement. And this previous statement already tested, already know that whether it is less than 2 or not. So this is already, again, redundant, okay? And else, if it's less than 1, so you get D. All right? So this will be the final code. So as you can see, depends on how many outputs you have, can have multiple else if statements. So if you have 5 outputs, you have A, B, C, D, E, then you will have another else if statement at the bottom before the else. Okay? So again, you can have as many else if statements based on the problems, how many outputs there are. Okay? Now, here, whenever we talk about if-else statements, so far the examples is such that if a certain condition is satisfied, is a Boolean expression returned true, you print something. Okay, you can also create a variable where the value of the variable change based on the condition. So here's an example. Okay, we use the same example as before. Okay. So we use the same example. So I'm going to use the same code. Instead of printing at every single step, I'm going to create a new variable called letter grade. Okay, so this letter grade will define what is the letter grade of the quiz score, a corresponding quiz score. So for example, letter grade will be A. If the quiz score is greater or equals to 2, then the letter grade will be equals to B, and then so on. So letter grade will be equals to C, else letter grade will be equals to D. Okay, so now I'm going to print, after I run this statement, I already know, after I run this if else statement, I know what is the letter grade. So I'm going to print, for example, your quiz score is something and is A or B or C or D, okay? And your letter grade is something. All right, and then we use dot format. Okay, so again, these are placeholder. It's going to replace it with the value that you put inside this dot format method. This will be your quiz score, and that will be your letter grade. Okay, so now instead of writing print statement at every single if blocks here, okay, I do one print statement at the end. I only write one print statement, and instead inside each of these block here, I put a name to the letter grade. So I put a value to the letter grade based on the Boolean expression here. Okay, and now for example, if I run here, say 3.5, all right, I get that your quiz score is 3.5 and your letter grade is B. So the advantage is that if you want to use letter grade again in the future, so say here, print letter grade A, say is excellent. So for example, I can have another if statement here. Okay, so if letter grade is equals to A, okay, or letter grade is equals to B, then you can print you pass. Okay, you pass the quiz. It's an example. Okay, so if you try it again, say 3.5 is a B, and then you will print that you pass the quiz. So the advantage is that now letter grade is defined, and you can use it again. Previously, you only print A, B, C, D, but if you want to use it again, we have to test again. So we have to do, say, if it's greater equals to 4 or greater equals to 2, then you pass the quiz. Okay, now here is that we can just use the letter grade that we have already defined based on the conditions, and we can just write it down or use it in the future, for example. So sometimes we create variables or change the value of the variables, depends on the Boolean expressions, and we put it inside our if statements here. Now, let's look at another examples. So a lot of time when we ask user for input, most of the time, I assume that the user enter correct input. Now we're gonna deal with the case now where the user enter input that is incorrect, okay? So for example, you are asked to create a program to get user to input a new password. You will display a message to verify if user input password is valid. If it's valid, if the length of the password is at least 8, it must contain a digit. Okay, good. So we ask user for a password, okay? And we will display whether it's valid or not. So we can create, for example, a variable is valid. So it's valid if the length of the password is at least equals to 8, and it must contain digits. So here, what is has digit? So has digit is a Boolean expressions that will set to true if it contains only digit. Now it must contain 1 digit. Okay, so here we have run this Boolean expression before. So I'm going to say, for example, if 0 is in password or 1 is in password, and so on. Okay, and another all Boolean expressions, 2 is in password, and so on, all the way to until 6 in the pass until 9 is in password. All right, so you're gonna continue here, or I can just pull it up somewhere. Okay, I'm just gonna put it here and just use the one from before. So this expression will be true if there's digits inside a password. All right, so we have has digit here. Okay, so it's valid now is equals to length of password greater equals to 8, and it has digits. All right, this is something we have done before. Now we're gonna have one statement here to display a message to say whether if the input is valid. So if it's valid, print say the new password is valid. Okay. All right, so else print is invalid. Okay. Invalid new password. So type again. Okay. For example, so we can, for example, test it. Say some password. It must at least a character must contain at least a digit. All right. Now we say the new password is valid. Now, if it's invalid, say it only contains characters, you say that it's invalid new password, type again. All right. So we first ask for what is the password. We check whether it has digit. Okay. This will be true if it has digit, will be false otherwise. This is a Boolean expressions that we have seen in our previous lecture. And then we create a variable, whether it's valid or not, where it combines 2 conditions. Length is at least 8 and it has digit. If it is valid, we're going to print the new password is valid, otherwise it's invalid. All right. Now, when you do something like this, with the user type in the new password, and it only know whether it's valid or not valid. So it's not informative enough. If you want to create a program, you want to be user-friendly, you want to tell the user why it is not valid. All right. So for that, for each criteria, if the users fail the criteria, you want to display a meaningful message to indicate why which criteria is not fulfilled. Okay. So here, for every single criteria that is that is violated, you want to tell the user it is not valid. So here, what we're gonna do is that if password is of length less than 8, okay, then you're gonna display, say, password must be of length at least 8. Okay, so if password it does not contain digit, then you display password must contain a digit. Okay, so for each of the criteria that the user input violated, you tell the user what's wrong. You say, for example, if the length is less than 8, you tell the user it must be at least 8. If the password does not contain a digit, you tell the user the password must contain a digit. Okay. If, on the other hand, if the user input did not violate this criteria, so if password is actually valid, then you display valid new password, for example, just any meaningful message. Okay. Now let's do this. Okay. So if you follow again, there are 3 if statements. If you do it direct, let's try to do it together. Okay. So again, I'm gonna run this. Okay. So I ask user for password. I have has digit. I have has length. So has large length, has long length, for example, is equals to length of password. Greater equals to 8. Okay, so I have 2 criteria. One is that it has to be long length. By long length, I mean it must be at least 8, and it must have digit. So if this is violated, we're gonna print. Okay, so again, if not has long length, so remember, the not is a Boolean operator. When you apply to an expression, it flips from true to false or false to true. If is not has long length, you're gonna print this statement. So if it doesn't satisfy that it has at least length 8, you're gonna print password must be of length at least 8. Okay. And also, if not has digit, if the user input does not have digit, again, you're gonna do print. You tell the user something is wrong with your part with your user input because it must contain the digit. Okay, so you tell the user it must contain the digit. And the third if statement, if the password is valid, if it's valid, okay, then you print valid new password. Okay, so we literally do as it is asked for. Okay, so for example, we run this. All right, so we have, if it does not have long length, if the length does not satisfy that it is greater or equals to 8, we print something. If it doesn't have digit, we're gonna print that it must contain the digit. And then if it's valid, we're gonna print that it is valid. So now we have, based on the criteria here, we have 3 if statements. Now, I'm gonna ask you to think, can you optimize it further? So what is being tested multiple times? So when this statement is gonna run, it's gonna test whether it has long length or not. All right, and then you test it again here. Here. Right? So you run it, you test it once, and then you're gonna test it again here. The same thing has digit here. You already test it once here in line 7, and you're gonna do it again in line 10. So again, you are doing a lot of redundant tests that is unnecessary. Okay, you don't have to check whether it has long length if or you already check it once. So if it's not has long length, you already know whether this is true or false. So you don't have to do this part here. All right, so what can we do differently? So to optimize this, okay, what we can do, so I'm gonna make them here. Okay. So again, I will keep this because I still need to display that user input has violated the condition. So I'll keep this and this, but I don't want to run this. All right. So how can I do not to run this? I want to utilize what I know already. Okay, so one thing we can do is that you can create a variable before the if statement and set it to true. Okay, so you create a variable is valid that is initialized to true. Okay, so it's think of it like a switch. So the switch is turned on initially. Okay, and you flip it off when it violated condition. And once it violated the condition, you never turn it back on again. So the same thing, is valid is set to true. If it's not has long length, then you know that it's already invalid. So you set is valid equals to false. So you flip the switch from true to false. Once you do that, you never change it back again. All right. And the same thing, if you know that it doesn't have a digit, then again, is valid is equals to false. Okay. So as long as one of these if statement has satisfied, is valid will be flipped to false. Okay. But if both of these conditions are not satisfied, that is, it actually has a long length and it actually has a digit, then this code here will never run. In other words, is valid will stay as true. Okay. So now you just have to do, if it's valid, you print this one. All right. So for example, we're going to run, say, some password contains digit, but has not long length, doesn't have long length. So a password must be of length at least 8. Okay. Then suppose it has short length and it doesn't have digit, it will print 2 conditions telling you that, hey, it must be of length 8. It must also contain a digit. And of course, if you key in the right one, say long length, but it doesn't have digit, it will tell you that it must contain a digit. And of course, if you key in the right one, then it will say valid new password. Okay. Now, we're going to extend this further. So again, this program is to update your new password, right? So we're going to do the same. You ask user for input. If you fill the criteria, you display a message indicating that the criteria is filled for each of the criteria. And then if the new password is valid, we're going to update the password. Okay, so suppose you have user password. Okay, some old password, for example. Okay, and you want to update this password, all right, based on user input if it's valid. So you first ask user enter a new password, and then you run whether this input has digit or not by running these Boolean expressions, and then you create another Boolean expressions and assign it to the variable that has long length based on whether the length of password is greater or equals to 8. And you first set is valid is equals to true. Okay, now this is valid will become false if it's violated at least one of the conditions that we mentioned. If it's not true, if it's not has a long length, is valid is equals to false. If it doesn't have digit, is valid is equals to false. And if it's valid, we don't just print valid new password. Okay, we're actually going to update the password. So update as in we're going to change the user password, which is the old password, to the new password that the user input. So what we could do is that we're going to do user password now is equals to password. Okay, so this part here is the new password. That's a user input, and you're going to assign this value to user password, which is stored in the database, for example. Okay, so for example, and then you can say print your new password. Your password is updated, for example. All right, so good. So we can run it, for example, enter a new password, say 1, enter something. So if it is true, if it's valid, then your password is updated. Okay, so now you can all check, say, user password. And previously it's this, okay? Now it's this, which is based on the user input, okay? Now if I key in, so suppose my user password is this. I'm going to stop it first. So suppose my current user password is this, and I key in a different value, but it doesn't satisfy the condition, okay? It says the password must be of length 8, at least 8, and the user password is never updated. It's still as before. Okay, so we only update the password if it is valid. Okay, now one thing is very important is that often students write code something like this. Okay. Okay, it's write code something like this. So if it's not has long length, so it's valid is equals to 4. If it's not has digit, it's valid is equals to 4. If it's valid, then you update the password. So let's run this one. Okay. It's gonna take some time. All right. Say, all right, DK, whatever. And it's no problem. Everything is fine. It say that this user input has length at least 8, is not valid because it must have length at least 8. It must contain a digit. All right. So you try again as a user, you know that it must at least 8 and must contain a digit. You try again here. Hold on a second. Let me rerun it. All right, let's run again this time. So I key in the password that is correct, that is valid. All right, when I run it, I get name error. Okay, what's this name error? It say that is valid is not defined. All right, then you think about why is valid not defined? So your password is a valid password, okay? So it doesn't satisfy these conditions. That means it actually has long length. So not has long length will be false. And so this is not executed. Not has digit is false as well. So this will not be executed as well. Okay, so its valid was never defined because line 6 and 7 was not executed. Line 10 and 11 were not executed because our user pass input is actually valid. So when these two codes are not executed, there is no way the computer know what is valid. Is valid was not defined anywhere else. It's only defined inside the block. Okay, so when we come to here, the computer doesn't know what is the value. It becomes very important to know that if you define or a variable inside the if statement, you should make sure that it is it is also defined if this statement is not true. Okay, so here I put a remark. Okay, create a variable. If you want to use a variable inside of this statement, so if a variable is created inside an if statement, if the statement is false, okay, the variable is not defined. All right. So remember when you want to use a variable inside an if statement, you should always make sure that it is defined outside as well. So one way we want to change it again, just like before, we should make sure that its valid is also defined before that. Okay. For example, I set it to true. All right. So here's a remark for you. And now that's all for today. And also here, today's in the lab for this week, we're going to talk about how to use these if-else statements, and you do some exercise. And one additional thing that I want to mention is that if you remember earlier on, when we ask user for input, for example, your name, your grade, and so on, we all assume the user make a correct input. All right. So for example, say ticket number to purchase is equals to input, enter the ticket number, okay, number of tickets that you want to buy, okay. And then we say that, for example, if ticket number is more than 3, all right, and then you print exceeded the limit. for example. Now again, when you do comparison with number, you typecast it to int, assuming that the ticket number can only be integers, okay? Now, when you do that, for example, say enter the ticket number, if the user enters, say 3, put here, then nothing happens, all right, because 3 is not greater than 3. So ticket number greater than 3 is false. If this is false, it will not print. Okay, for example, you can say else print purchase ticket numbers. Okay, number of tickets is, say number of tickets is ticket number. Okay, so here, for example, say 2, number of ticket is 2. All right, now if I run, for example, if the user types something different that is not a digit, okay, you get a value error. Now we want to not let the system crash. We don't want the value error here because we want to make sure that it can run again. The user can run again or can key in a different number again if it's invalid. So what we can do is that we first check user input whether it's an integer before you do the typecast. Okay, so before you do the typecast, you first check whether it's an integer. If ticket num is digit, then only you do typecast. Okay, if it's not digit, you immediately tell the user print invalid input. Okay, else, then you run the computation earlier. Okay, else you're going to do typecast. So ticket num int is equals, or ticket num is equals to int of ticket num. So you only run typecasting after you know that it's a digit. Okay, so if it's not digit, we don't run this statement. We don't do typecast. We just print it's invalid. But if it's not a digit, if it's a digit, we do typecasting, make it into an integer, and then we do the following test. So here's an example. Say if I type 4, it says invalid input. There is no value error here compared to before. Before, I get a value error if I put on something that is not digit, but now there is no error. It just tells the user it's invalid input. Now, if I put on something that is, say, a number, it just say that it's exceeded the limit. Or if I put in a number that is less than that, it just say the number of ticket is 2. Now, this is what you want to do when you create a program so that the program will not crash. Okay, you first check whether it's a digit or not before you do typecasting. Okay, this deal with the case when the user input is invalid. Assume that we don't make an assumption that user input is always valid. All right, so we can continue with the lab. So there are things that I want to tell in the labs, and so please look at the video that will be uploaded by the end of today. So please watch it. There are additional things that I want to talk about the user input validations. Okay, thank you, and please get ready to do your quiz for